So question P17, another one on projectile motion, says that a stone is thrown with a speed of 14 meters per second at an angle of projection of 60 degrees. Find the greatest height reached, the time of flight, and the horizontal range. Okay? So we would need to understand what we mean by time of flight and what we mean by the horizontal range. Okay? Let's do that now. Right. So this question is asking us to find the time. So the object is projected at 14 meters per second at an angle of 60 degrees to the horizontal. We want to know its maximum height. So how high is it above the ground, the highest point on its projectile path? How high is the object before it comes down to the ground? Okay. The second part of the question is asking us to find the time of flight. The time of flight refers to the time from when it is projected until it eventually hits the ground. Okay, so if we can find that time, that is called the time of flight. And the horizontal range refers to the distance from where we projected it until where it hits the ground. So what's that horizontal distance? The symbol we normally use is capital X, and that will be referred to as the horizontal range. So I have put the object right at the maximum height so that we can look for its maximum height. Okay. I'm going to just try and derive a relationship for the maximum height. To do that, we first, because we are talking of maximum height, we need to be thinking about vertical component of the velocity. The horizontal component is 14 cosine of 60. The vertical component is 14 sine of 60. So I might as well write that here. This is 14 sine of 60. That's the horizontal component of that velocity, and the vertical component of the velocity is going to be 14 cosine of 60. Okay. Now, I think the first thing I need to do here is to derive the formula for maximum height. Okay. So the time taken to reach the maximum height, we can use motion in the vertical direction. We can say that the final velocity in the vertical direction is the initial velocity in the vertical direction plus a times t. Now the final velocity is going to be 0, vertically speaking. Okay, so it starts with a velocity of u sine 14 sine 60, but eventually vertically it will stop and then start coming down. So the final velocity is going to be 0, but the initial velocity is going to be u sine of theta, not just u, but our u here 14 sine of that, and then this is minus g times t. So therefore the time taken to reach the maximum height is going to be, make t the subject of the formula there. We get t is u sine theta over g. Okay, so that's the time taken to reach the maximum height. Okay, if this point is in the horizontal, that means that point and that point are on the same level, then this projectile is symmetrical about the vertical height, which is to say that the time taken to start from here to the maximum height is also the time taken to, from the maximum height back to the bottom, which is to say that the time of flight, this is time taken to reach maximum height. Okay, time to maximum height. Okay, now the time taken to reach the other end, which is called the time of flight, is therefore going to be twice the time of flight, twice the time to the maximum height. So let's use this symbol here to represent the time of flight. So the time of flight is going to be twice the time to the vertical height, which is 2u sine of theta, everything over g. So that's called the time of flight. That's the formula we'll use for the time of flight. On the other hand, so the maximum height then, to reach the maximum height, now we can use the formula maximum height is u sine of theta, that is ut plus half at squared. This is going to be a half gt squared. But we've just found that the time to reach the maximum height is given by this formula here. So we can write that h, I think I'm going to have to write somewhere up here. So we find that h is therefore going to be u sine of theta multiplied by t, and our t is u sine of theta, everything over g. and then we're going to have to subtract a half g times t squared. Our t squared is u squared sine squared of theta over g squared. If we simplify this, we see that the height, the maximum height, is going to be u squared sine squared theta over g minus a half of it, half, because this cancels with that, and a half u squared sine squared theta divided by g, which is to say that the maximum height, I will now use capital H, so this maximum height is going to be 1 of this minus half of it is just a half of u squared sine squared of theta everything over g. And now all I need to do is make my substitution. It's going to be u squared. Our value of u is 14, so 14 squared times sine of 60 squared, sine 60 everything squared, everything over g, 2 times g, which is 10, like that. If I substitute this in my calculator, we get 14 squared times, into bracket, sine of 60, close bracket, and squared, and then everything divided by 20, and that is 7.35 meters. So the maximum height is going to be 7.35 meters, okay, because the speed is in meters per second, so the maximum height that this object reaches is 7.35, okay. Part 2 of the question is asking us to find the time of flight. The time of flight can be determined using this formula now. All right, let me remove this. So the time of flight, I can also remove this now. So the time of flight is just 2 multiplied by 14 multiplied by sine of 60, everything divided by 10, like that. So what does that give me on the calculator? It is 2 times 14 times sine of 60, and everything we will divide by 10, and that gives me 2.42. 2.42 seconds is the time of flight, okay. The horizontal range is simply calculated from horizontal range. That means distance is horizontal velocity multiplied by time. Horizontal velocity is u cosine of theta multiplied by the time of flight, the time taken to start at that end to this end. And so the time of flight we've already calculated. So this just becomes 14 multiplied by cosine of 60, which is really just a half, and then we multiply by this value we got here, which is 2.42. If we multiply this, we get 7 times 2.42, 14, 29, carry 2, 14 and 16. So this then becomes the horizontal range, x, like that. All right, so this is how we would answer this question. I've probably didn't organize myself well, but hopefully you've understood how to work out this question. All right, thank you very much. I'll see you for the next question.